Downstream of the sand trap, again, you can see everything's flanged, welded with cushion tees. We have 3-inch going into the inlet of our gas production unit. The gas production unit consists of a separator, a 3-phase separator, and an indirect water bath that we have a burner that will keep our water bath temperature up to roughly an average of 100 degrees to help heat up that gas so we can be in compliance to pipeline specs and to stay out of what we call a hydrate window. So we like to try to keep our gas temperature above 60 degrees and below 90 to help us stay in compliance with the pipeline. Inside that bath, you can see by the flow, we're going into this indirect water bath. There's coils that run in and out of this, surrounded by that warm glycol, 100 degrees, choking the pressure and flow with what we call a manual choke. Some units have an automatic choke that we're starting to implement on some of our newer designs, where we can adjust that through an app on our phone or through SCADA off of our laptop. This is kind of the hands-on way that we will adjust flow by either opening the valve more to allow more flow or pinching it back to slow down the flow based on current conditions, capacity limits. Newer wells have higher pressure. We want to try to keep that under control. Part of after going through the coils and the water bath, we have a second inlet valve here that will shut in relation to the ESD over at the well. This is a second barrier. In case there's valves leaking by over at the wellhead, this will help eliminate any flow that we need to have stopped. So part of our maintenance program, the guys check, make sure there's no leak by checking our safety shutdowns periodically, for sure at least once a month, if not more often. As we go through the production unit here, I'll show you some devices that we have set that will monitor pressure. As pressure gets above certain set points, this will start to trim back this valve and throttle back our flow. This is a single unit that we've gotten from RBI. We really do like the design from an operator perspective. Very easy to access mechanical parts to be able to work on things, maintain. What we have, like I said, this is a 3-phase separator. You can see this big vessel here. All of our production, which would be the gas, water, and condensate, will free flow into this unit and be separated just by the density of the element that we're producing. Water is going to be the heaviest of the three. It'll settle in to the bottom, bigger voided area of the separator. We have a dump controller that's operated by a float. When that fluid gets above that float, it'll cause the dump controller to call for a dump and open that dump valve that was on the outside of the unit and allow that fluid to drain down by a difference of pressure. All that fluid, the water, brine, will be stored into the production tanks. Downstream from there would be our condensate stage, second stage of the 3-stage unit. You can see that's a little bit higher compared to the water stage, and that's because that oil will be settling in on top of that fluid, and by what we call a weir plate, that'll spill over the weir plate, start to fill up this stage for the oil. And same as the water, when that float gets to the point where it'll open and lift the pilot in here to create that dump valve to open up, and just by a difference of pressure, that'll be removed from this separator. Gas being the third and last of the stages of production will be the lightest of the three elements, and that's just going to be on the top part of the vessel and free flow through the flanges and piping to our sales meter. This is our sales meter where we're going to be measuring our gas flow. That's all measured by what we call an orifice meter. There's a plate in here. We'll measure the high side to the low side, and by different calculations and formulas. And this transducer will calculate how much production that we're moving through this unit from that one particular well. Some of the safety devices that we have in this unit is this controller, which is our high pressure controller. When we get above a certain set point, that'll start to throttle back that inlet valve when we're getting out of where we feel comfortable producing our gas. It'll throttle back and actually get to the point of shutting that valve and stop flow, protect us from overpressurizing the vessel, and mainly due because of a compressor station going down or a curtailment or potentially a hydrate issue downstream. But this will protect us from overpressurizing the vessel and creating a mess. If that was to happen, we do have devices on these vessels called pressure relief valves. Those are set to release if we do get to the point where this had failed and we're overpressurizing the vessel. That will open up and release that pressure off of this unit to help protect us from having any catastrophic issues. We do monitor the pressure of the vessel by this transducer that's tied into our PLC. Also the shutdown safety devices. If we get on high pressure, we're slipping by, a valve is leaking by, it'll protect us and shut the valve at the well. It'll shut the inlet and send an alarm to an operator. Same thing on the low side. If we have a breach, it'll protect us from a low breach to the atmosphere or in the environment. That'll shut us in on low or high pressure. This is a thermostat. This is what we use to control the temperature of our water bath. Remember, we have a burner inside this indirect water bath that's going to be heating up those coils. So we use this as a thermostat to be able to adjust the temperature to whatever. We usually try to run about 100 degrees. We have a temperature readout here, and this is a second thermostat that we use to control temperature in the separator itself. Based on the amount of water, oil, gas, that will vary by the amount of flow, so we can adjust it up or adjust it down as needed. We do have safety shutdowns also in relation to that, where for some reason our burner, these thermostats weren't working properly. We will shut down on low temperature, high temperature. It'll shut the fuel supply off to the burner and send an alarm up to the operator. We have some sight glasses here to be able to track how much fluid that we currently have and helps us adjust the levels that we're looking to have set off of our dump controllers. We do have a device on here for a high level. If we were to have a failure of one of the dump controllers, we don't want to carry liquids over into the sales line. So if that liquid gets up to a certain level, that'll shut us down on a high level condition, send an alarm out to the operator and stop flow to the unit. If that fails, we do have a second backup that will fill up this knockout bottle with a mechanical flow in it. If that fluid was to get above this level here, it's going to trip supply to our high pressure device that we had talked about earlier and close the inlet to the valve, and we'll get a low flow alarm for the operator to come out and troubleshoot and see what's going on, see if they can get things back rolling. We do measure as far as the amount of fluids coming from the unit. We have the orifice meter for our gas stream. We have what we call a turbine meter or spin meter for our water side. This is when we open up, it's going to spin an impeller, send a pulse signal to a water meter and track that through our PLC to SCADA and to the operators and myself and supervisors. As far as the oil or condensate, we measure that by a device called a Coriolis meter. This is measuring density, which is old school kind of measurement. They use these in cement plants, drains. There's just tubes in there. Flows through the tubes, creates a frequency, sends a signal to a PLC, and through some calculations, we come up with the amount of production that we're moving through there. This will track density of the condensate. If we have a dump hanging open, it's going to give us a low density alarm. If it carries water over to the oil, which we don't want, that'll give us a high density alarm. That will actually shut us in. Again, an operator will get an alarm and he'll come out and address it. Try to figure out what we need to do to get back online. Here we do have the water measurement, which is coming off of this device tied into our PLC to track how much fluid that we are making as far as water goes. This device here is an LEL monitor. That's a lower explosion limit monitor. If there is a leak of gas in here in this unit, this will pick that up and it will shut in the well if it gets above a certain parameter. It'll also shut all the ignition sources on the pad off. So any other units that are next to this particular production unit will shut off the burners on everything on location. Any other units that are flowing in here will be extinguished. And also we have a combustor on the downstream side, which we'll talk about in a little bit, of our production tank. It'll also shut the pilot off on that device also. Again, we'll get an alarm and we'll come out and address it and see what's going on. We can walk around to the front side of our gas production unit and kind of talk about how we keep heat into our water bath. This right here is our burn tube. There is a pilot that would be lit and burning all the time on this unit when we are operating. And by those thermostats, when we get below a certain parameter, when it needs fuel, it'll open up a fuel valve to allow gas to go to the pilot and light that burner to continue to heat up that water bath to our desired temperature. And again, if for some reason this was to go out, we get below a certain parameter, it's going to shut the fuel supply off inside the gas production unit. We'll get an alarm and address it as needed. Okay, and then as far as flow, like we talked about the water and the condensate, this is an insulated line that we wrap all of our condensate lines in due to temperature drops. Normal to have cooler piping and condensate. As it flashes, it drops temperature. So to eliminate hydrate potential, we'll wrap insulation. We have heat tape wrapped around the piping and insulation to help keep that heat on the pipe and utilizing it as needed. So all of our condensate will flow towards the gathering system side. The other 2-inch line here is our water production. That will flow over to our water production tanks to allow that fluid to be able to evacuate into that next step.